Welcome. All right, I am glad you are watching this lesson because it is a key one to understand. All right, let's jump in. We're going to graph some sines and cosines. All right, so whether you were in class or not in class, here's how this played out, is that I gave everybody in the class a handful of angles that they had to find the sine value of, the cosine value, and so forth, all 6 trig functions. And then what we're doing is we're making this great big old XY table. And so here's what the results of that were. So these were the angles that I was given, and there's more. This is just where it cut off. And then this is the sine value that y'all found for me. Now, what this is this is your X and this is your Y. So looking at, here's what it looked like when we graphed it. Here's my X axis. This is the degree measurements. And this is my Y axis. And so what happens is that it falls in this nice flowy wave graph. This little guy right here looks out of place. Probably was supposed to be a negative if I had to guess. All right, but overall, a beautiful graph. Now let's talk about how that graph compares to our unit circle graph. All right, I have this great little website that shows this beautifully, how the two connect. And it's an animated thing, but this is the best I could go for animated here. So what I've got is this right here, unit circle. Now we're doing the sine value, right? So the sine value right here is 0. So when your angle is 0, the sine value is 0. So you can see right here on our wavy graph that that's 0, 0. But as this angle gets larger, then your sine value starts going up. So now you're up to here. Okay, so as your as you move to the right, as your angle gets larger, so does your sine value. And so then it keeps going, you keep going, you keep going. Oh, now you're straight up. Well, that's a 90 degree, right there at 90 degree. You're as high there for a sine value as you're ever going to be, because then you're immediately going to start coming downward. So the sine value starts decreasing. So you can see here, now it's starting to decrease. And when you get, I kind of started skipping over things, but right here at 180, your sine value is back at a 0. So that's happening right there. And then if you keep on going, it keeps heading down. Now we're negative, so we're below the x-axis. And I bet you could tell me where we're at right here. We'd be straight down at 270. Okay, so that's kind of the process. And then it would keep on going until you hit 360. So ultimately, here's what your wave looks like. You're starting at 0, 0. You go clear up to 90, come back and cross at 180. Now you're bottomed out at 270, and you're back up at 0 when you hit 2 pi. So that right there equates to 1 sine wave, or 1 revolution of your unit circle. All right, now ideally you have this special handout that has just the graphs of the 6 different trig functions. I just kind of wanted it all in one place for you. You can put this in your notes, but it's better to put it in that other document. Okie doke, so here's what I've got. We're just going to put this and recreate that graph so we have it in our notes. So for the sine graph, remember that it starts at 0, 0. And I'm going to be back at that same spot when I get to 2 pi. And this is the shape that I'm trying to get to happen. I'm trying to go clear to the top, come back down, come back. There's the 1 sine wave, and I land at 2 pi. Now, we did ours in degrees, but we're going to convert that into radian measurements. All right, and this idea of how we're going to graph this is how we're going to graph all of these. So we've got our first point and we've got our last point. And if you look smack dab in the middle of those, I'm crossing the x-axis again. So let's go ahead and put a dot right there. And then in the middle of this extra x-intercept and your first dot, we're at a peak. And then between the other two, you're at a valley or a minimum there. So let's go ahead and put that in. Now, you have to pay attention to what the scale is here. This y value goes clear up to 5, but that was stopping at 1. So it really just goes to there and to there. All right, that is 1 sine wave. But we want to go ahead and continue that farther. We want to do another wave. So look at the pattern of your points. It looks like we're putting a point every 2 grid lines. So that means I would be another 2 grid lines. I'd be back up. Then I'm at the middle, down, middle, and I got another sine wave in there. If I were to go left, because some of you did have negative angles, so following the path of that, I would be right. Oops, did you catch that? I went down too far on that other one. Did you see that? Right there, that guy right there. He's only at, oh my, I got crazy on the whole thing, because look at that guy. It was just too small for me, I guess. Here we go. Back to 1, 1, 1. Sorry, my bad. All right, so then I'm going to back up and go to there and there. All right, nice flowy wave. Not pointy, make it curvy. Connect all your points. Make sure you're hitting those points nicely. Sorry, I'm kind of doing this blindly. Boom. There we go. There's a nice sine wave. Okay, the sine graph is considered to be a periodic graph because it starts to repeat itself. And so the period is the range in which it takes to make a full wave before it just starts over again. So this is my one full wave. So after that, it just repeats itself. So one full wave happens in 2 pi. So the period of sine is 2 pi. The domain is just like every graph, how far left, how far right. Your domain here is negative infinity to infinity. Nothing fancy there. Your range is your possible y values. So that's how low does it get and how high does it get. And you're limited there. The lowest it ever gets is -1, and the highest it gets is 1. And it does actually hit those values. So those are brackets. All right, so there's your sine graph. Let's take a peek at cosine. All right, this is the result of our big table that we created together as a class. Here it is. But at first glance, you might think, oh, it's the same thing. Not quite. This is the cosine, so these values are not the same. Notice on this one, it doesn't start at 0, 0. It actually starts maxed out. Let's look at why that would be. Well, think unit circle. I'm not going to go back to that same diagram, but think on your unit circle. I'm just going to squeeze in a little drawing here. If you think on your unit circle, when your angle is 0, your cosine is 1. That's the farthest, cosine is your x, so it's the farthest to your right you're ever going to be. So your beginning spot is the highest spot it's ever going to be. So cosine starts maxed out. And then as you start to wrap around the unit circle, your x value, it's starting to come inward. And so your x value is decreasing, decreasing, decreasing until you get to 90. And at that point, your x value is 0. So you can see right here, I'm at 90. This is the 100 line right there. So at 90, I'm back at 0. And then my cosine is going to start going negative on me. Oops, looks like a stray dot right there. So it's going to start to go negative because your x value is over here. So you're negative, negative, negative until at 180, you're at -1. And at that point, at 180, you're at the bottom, and that's the lowest or farthest to the left it's ever going to get. And then it keeps on going around, and then it keeps working its way. So we started at the peak. The next time that it's at the peak is going to be clear over here at this value, which if you look down is going to be at 360. So the period of cosine is also going to be a 2 pi. It just looks a little bit different as far as what that one wave looks like. Let's go ahead and graph this on your master graphs, okay, or in your notes, whatever. Okay, so cosine starts at the peak of its wave. So it actually starts right here. And the next time it's going to be at the peak is at 2 pi. Right, so what a cosine graph looks like, it starts at the peak, it comes clear down, comes clear up, and ends at a peak right there. So what we've got then are the 2 peak spots. So smack dab in the middle of the 2 peaks is your valley or the minimum. And so that's going to happen at pi right here. Think on your unit circle. At pi, your cosine would be your farthest to the left, so you're at -1. And between maxes and mins there, you're going to have x-intercepts. So there is a single wave. And then we'll keep that going again. Every 2 grid lines, we've got a dot. Let's keep the flow going. We can also go negative. All right, and then make a nice curvy wave. All right, let's fill in our info. Period, still 2 pi. Domain, still negative infinity to infinity. And range, still negative 1 to 1. All right, so what we just graphed were what we call the parent graphs of sine and cosine. Now what we're going to do is we're going to do all that transformation stuff that we know how to do with square root functions and quadratic functions and all the functions that we've learned. We're going to now do it with sine and cosine. But in trigonometry, sometimes there's some special vocabulary that we use. So we're going to break down all the different things that we can do and talk about some of that vocabulary, and then we'll try a couple graphs. So to start with, this is kind of the general form of a sine function. It will also work the same way with a cosine function, but these examples are sine. And so think of that quadratic, that parabola. We know how that all works. So let's go left to right on this. A, this value right here. All right, ideally, you know that that is your vertical stretch and shrink. It can also be a reflection, so keep that in mind. It might flip your graph upside down or flip it vertically over the x-axis. The other thing to consider is that a value, if that's going to stretch your graph, it's going to stretch it both directions. So if my normal graph, let's say, looks like this, and I'm going to stretch it, let's say it is a 3 value, 3 for that a value, it's going to stretch 3 times what it used to be. Well, what ends up happening here is the total height of that wave, let's say, would be 6 if I had made an a value. So, but because it stretches up 3 and it stretches down 3, then that a value is always half the height of your wave. So keep that in mind for later on. The other thing that a value is how far it goes up and down from the equilibrium. There's one of those new words, a vocab word. The equilibrium is the middle of the graph where you're stretching up and down equally from the middle. That's your equilibrium. All right, so A does have a special name. It is called the amplitude. It's not an A for amplitude, that's just a coincidence. But the amplitude tells you how far you're going to stretch up and down. Now, officially, the amplitude is always a positive number. So even if that was a -3, we'd say that the amplitude is 3. And that's why I have the absolute value here to indicate you always keep it. Now, that doesn't mean it doesn't reflect. It could still reflect, but our amplitude number would be positive. Okay, so I gave you just a little basic one. This is not the parent function because I have an a value here. So what is this a value going to do? Okay, now you can write this down if you want, or I'm just going to do it orally. I'm not going to take the time to actually write the transformation, but we always want to do it left to right. So the first thing that I come across is this negative. So I would say that this is going to be a reflection over the x-axis, and this 4 is going to be a vertical stretch by a factor of 4. So that's going to stretch it up 4, stretch it down 4. All right, now the next part is a little bit more challenging to kind of figure out. B, because we don't really use the B very much. I'm kind of nice about that. B is kind of the trickiest thing to deal with. And so I don't usually give you a negative in here, and I won't with the trig either. And sometimes I don't even give you a number here, but in trig, we will have this number. So this B is, because it's being multiplied by the x, is going to be a stretch or shrink. But because it's inside your parentheses, tucked in with the x, it is a horizontal stretch or shrink. You can use the word compression if you prefer. Now, if it's a horizontal stretch and shrink, what it's doing is it's changing your period. So that period, if you shrink it, it's not going to end up being 2 pi anymore. Or if you stretch it, it's going to be longer than 2 pi. So we have a little formula that we use, and we say that the period is equal to the parent period divided by that b value. Now, the reason that I write the parent period is because it will not always be 2 pi, but the parent period for sine and cosine is 2 pi. And so that's what we'll use today. It'll be 2 pi over b. All right, so if you think about this, b is inside the parentheses, and anytime you're inside there, you always do the opposite. So when you see, let's say the b value was a 4, that would feel like it should be a stretch, but it's not, because you actually end up dividing by the 4, which is going to make your period smaller. And so as b gets larger than 1, the bigger it is, it's actually a shrink. So if you are dividing by the 4, then your period would shrink by a factor of 1/4. All right. If b is smaller than 1, like maybe it's a 1/4, that's actually a stretch. It's going to be stretched 4 times longer. All right, so let's look at this example, and we're just going to go ahead and do this orally. Not going to take the time to write it, but if I see a 2 right here, all right, so that's going to be a horizontal shrink by a factor of 1/2. All right. Okay, next one is this c value out at the end. And this also is caught up inside here, so it's a little bit tricky in that this b value affects that c. So for this c to be the horizontal shift that we all know it is, it actually is not this c. You have to factor out the b before this number really indicates the horizontal shift. All right, now your horizontal shift has a name. It's called the phase shift. Instead of just horizontal shift, we call it phase shift. And it is actually the value after you factor the b out of the parentheses. And sometimes I go ahead and I'll do like brackets kind of to see that what just happened there is this is all still part of the parentheses, but I've factored the b out. So it looks like this. So this c value will change as you factor out the b. So these two c's really aren't the same c value. But the one we want is this one. This one is actually going to be the phase shift that we want. All right, let's try the next couple examples. Going to just talk through them orally. So in this one, the only thing I have is this minus pi. All right, there's not a b value to worry about. So this right here is my phase shift. It is a minus, and remember, you always do the opposite. So I'm going to move right pi. That's what that means. All right, this is a fancier one. This time I put a b value in it. It's a 1/3. Remember, when you factor, what you're really doing is dividing. So when I factor out the 1/3, let's think about what that's going to do. I'm going to be dividing by 1/3. Pi divided by 1/3 is the same as multiplying by the reciprocal, so multiplying by 3. So this would be a 3 pi. And you can always check that by redistributing. Do you really get what you want to get? Yep, we do. Okay, so now I'm going to go through my transformations. Have to go left to right. So the first thing I come across is a b value of 1/3. All right, remember, we do the opposite. So that feels like it should be a shrink, but it's not. This is a horizontal stretch by a factor of 3. So when the period used to be 2 pi, it's now going to be 6 pi. All right, it's also going to shift now to the right, because we do the opposite, 3 pi. Not using this one anymore. All right, we got one more. This one is the d value at the very end, and we know from all of our other functions that that's a vertical shift. It's outside the parentheses, so we do what it says. If it's a plus, we go up. If it's a minus, we go down. All right, if you can imagine that moving up and down, that actually is going to take, like if you think of there's my x-axis, and then here's my sine wave. But if I'm going to shift the whole thing up, what it takes up with it is that equilibrium point. And so now when I shift it up, whatever that was that I shifted up, that V value that I moved up is the equilibrium value. All right. And sometimes they'll put that D in the front, but only in trig. They don't do it with the other functions, but in trig, they like to put the vertical well, I haven't even told you what the word is. It has a special name. This is called the vertical displacement. And so sometimes they'll put that vertical displacement value on the front end. So pay attention to whether you are looking at this as an A or if it's a D. If it's being multiplied, that's an A value. If it's the D value, it's going to get added. You're going to see addition there. All right, here's the monster right here. Everything I could possibly do to it, I did to it. So your first step is always going to need to be to get this B value out of here before you jump in. So I'm going to rewrite this. Dividing by 2 is going to make this be a negative 3/2 pi, or 3 pi over 2 plus 1. All right, let's do a couple examples. Okay, the key things you got to look for here that we have to remember is that a sine graph is going to start in the middle, head all the way to the top, come back down through the middle to the bottom, and back up. That's what a sine graph is going to look like. Whereas a cosine graph is going to start at the peak, come clear to the bottom, and back to a peak. And then these are kind of the steps in which you're going to graph. First thing, we can't forget to factor that B value out. Sometimes it already will be, but most of the time probably not. And then you're going to go through those 4 features that you get from the A, B, C, and D. Now, determine where you want to start. Now, really that's back up to this. Sine starts in the middle and heads upward, or cosine starts at the peak. Or you can always go back to your unit circle and remember at 0, what's the sine value or what's the cosine value. And then we're going to plot our key points, so beginning to end and where it crosses the x-axis, your peaks and valleys. And then we'll try to always get at least 2 waves, if not maybe more, on our graphs. I'm going to start with a little bit more basic one, and then we'll get a little bit harder as we go. I got 3 of them we're going to try here. Okay, so this one says y equals 3 sine of 2x. Now, I could factor out the B value, but it really isn't going to do anything because I'm not adding or subtracting. So there would be a scenario where it's not all that important to factor the B out. Okay, in this case, I've got my amplitude. That comes from your A value. So the amplitude is 3. So it's going to stretch up 3 and stretch down 3. The period is going to be your formula, 2 pi over B, so 2 pi over 2, which is going to reduce to just pi. So this is a horizontal shrink. So instead of taking 2 pi to start repeating, it's only going to take pi. There's no phase shift. Go ahead and put a 0 there so I give you credit for it. I am looking for these 4 things. I'm giving you credit for filling that out. So if you mess up your graph, you can still get some partial credit. Your vertical displacement is 0. So even if there's nothing going on, put a 0 there so I know that you knew. That's why you didn't just skip it. All right, so again, a sine graph starts at the middle, heads all the way up, all the way down, back to the middle. So it's going to take pi units to do that. So my first dot is right here, and my last dot is right here. Halfway between the first and the last is another x-intercept, so I'll put my x-intercept in there. And then I'm going to be at a peak first and then a valley in between. Now my peaks and valleys, remember, are going to stretch to 3s. So it's going to look like that. Okay, let's do that another time. So I've got the one wave going here, but I want to keep it going. So it looks like every grid line I have a dot. So here I go. I'm at the middle. Now I'm at the peak, middle, valley. middle, yep, sorry, I missed a line there, valley, middle, peak, middle, valley, middle. That's probably enough. All right, let's get a nice flowy, not pointy graph. Okay, there it is. All right, let's do one that has a little bit more action on it. So definitely more going on here. There is a b value that does need to get factored out. This is going to be a cosine graph instead of a sine graph. So I'm going to factor out the 1/2 x minus. All right, so when you do this, you're dividing. When you factor out, I am dividing by 1/2, which is the same as multiplying by a 2. All right, let's go down and fill out our information. We have an amplitude that comes first. And this is just what the numbers are left to right. So the first thing is your amplitude, that's 2. Then I have a period that's going to be 2 pi over the b. And the b in this case that I factored out was 1/2. So 2 pi divided by 1/2, you're popping that up and multiplying by the reciprocal. I end up with a 4 pi. I also have a phase shift of 2 pi. Notice that I'm using the number after the b is factored out. And it is a minus sign, so that's going to shift to the right. So all I do here is I just make sure this is positive. If I wanted to move to the left, then I would make my phase shift negative. There is no vertical displacement on this one. Okay, so here's how I graph it. When I start having this much stuff going on, I know that this is a cosine wave, and this is supposed to start at the peak. So it's not going to start at 0, 0. It's actually going to start at the peak up at 2 because of the amplitude. So I would be here headed down. But I'm not going to put that dot there because I sort of need to go through the list. So I'm hovering. I take my pencil and I kind of hover right here. Now, the period is 4 pi, so it's going to be a long stretch. This is going to be a long wave. It's going to take 4 pi units to make that happen. But this is really the thing I was waiting on. It's that phase shift, because my first dot is not going to be here. It's going to be 2 pi to the right. That is my first dot. Now, I'd also have to adjust it if I had vertical displacement, but I don't. So this is the dot that I have that I really want to put as my first dot. All right, so that's the first peak. I'm going to go peak to peak. And if you think about this, I think I'm going to need more than just one. So what I have right now is this dot. The problem is that my period is 4 pi. So if I'm starting at 2 pi, the next spot for the end of the period is at 6 pi, and that's way over here off my graph. And it's off my graph this direction. I can't even go backwards. And I might have a little bit more room to do it backwards. So I could maybe estimate, depends on how much room on your notes packet there. But what I could do instead is kind of think of, well, if it's 4 pi to get from here to here, it would only be 2 pi to get from here to here. So I could go 2 pi and put in a minimum. I could go 2 pi and put in a minimum. And that's how I'm going to have to get my points in there. So 2 pi, I'm at a minimum. And 2 pi the other way, also at a minimum. And between maxes and mins, I'm crossing the x-axis. So this is stretched out way more. I've got a point every 4 grid lines. So I might go ahead and throw in this extra x-intercept. And that is going to be then the key points for my cosine graph. So anticipate with those problems that have a bigger period like that you're going to have to do some stretching and kind of picking out other points other than always the beginning and the end. All right, here's my last one. Again, last one's always the fun one where I do a lot of stuff. All right, first thing I want to do is I want to factor that b value out. So it's a negative sign. Factor out the 2. So I am dividing by 2. pi over 2 divided by 2 is the same as multiplying by 1/2. That's going to end up a pi over 4 plus 2. All right, so now let's go find out our key information. The amplitude, well, there is no number there, so we assume there's a 1, but it is negative. That is going to reflect. Remember, your amplitude has to be a positive number. So my amplitude is 1. I like to remind myself, because otherwise, by the time I get down to it, I've forgotten that this is going to reflect. So I make a note to myself that it will reflect. All right, the period is going to be 2 pi over b, and b was 2, so the period is pi. Your phase shift is the version after you've factored the b out, so I'm going to move to the right, so I'm going to make my phase shift a positive pi over 4, and then I have vertical displacement. The whole graph is going to move up 2. Now, to be honest with you, I'm going to put that on hold, and at the very end, I'm just going to take all my points and move them up. I find that we lose track of where our intercepts are when we're up kind of in the middle of nowhere because we've had that vertical displacement. So I'm going to do that at the very end. All right, so here we go. I'm going to hover. I'm going to hover sine, remember, starts in the middle, heads up, back down. So I'm trying to get these first and last points in there if I can. My period is small enough on this one. I think I'm gonna, but I just hover here because I might have some movement on this. So I'm only gonna stretch to 1 because the amplitude's 1. The period is pi, so it's gonna be a short little wave. But right here's what I was looking for. That phase shift is gonna be at pi over 4. All right, that's gonna be 1 grid line. And then remember, hold on to the vertical displacement. We'll come back to that. I've got this dot right here. Now, the period is pi. So that's pi is 4 grid lines. So to get from here to here is going to be 4 grid lines. So I'm going to end right here. And halfway between those is another intercept. And then I do have a reflection. So instead of being at the peak, I'm actually going to be at the valley. And then I'm going to be at the peak. So those 2 points kind of got reflected. So there's your general flow of your graph. So let's put in another wave or 2. So I'm doing a point every grid line. Also could go negative here. All right, I'm going to call that good. Oh, no, I'm not going to do that. What did I forget? Okay, I haven't done my vertical displacement. So now I'm ready to take all of those points and I'm going to move them up 2. Up 2. And then you can get a better feel for where that equilibrium is. Now, another option could be to draw in a very light equilibrium line. I'm trying to talk and do my points at the same time. Okay, sorry. All right, let me go ahead and graph. All right, so what some people do is go ahead and they try to do the vertical displacement at the same time as all the rest so that you don't have to come back and do this. What they'll do is they'll put just like a very light equilibrium line in there to remind them like that's the new x-axis. That's where all the intersections are going to happen. Now, that shouldn't be part of your final answer, but if you make it really light, it'll help you keep track of where your equilibrium is on these. All right, that's all I've got. Go check out your homework and give it a shot.